Okay, pretend for a moment that we do not know that ex is the inverse of log x, but keep in mind that log x has an inverse, call it e. Show that I'm going to use x rather than t. So show that the derivative of the inverse function. So that would be the derivative of e over the x. So that's the derivative of the inverse function, the derivative of the log inverse function, whatever that is. And there's a rule that says that this is 1 over the regular derivative, but the situation is the variable changes, so it's not quite x though. This would be 1 over x at the value, which would be x at the value. And I want to kind of use the letter y, but this came up when we were doing this derivative of inverse. So it's not x, but it's the x that gives y, where we have y equals ex. So if you just remember the theorem, suppose you have like y0 equals f of x0, and then you want the derivative of the inverse function at some particular point, call it y. So maybe we should use the y variable here. That would be 1 over the derivative of the normal function at x, but the value of x you're supposed to use is the x that would give say this is y0, it's the x that would give y0, so that would be x0. So it should be 1 over the derivative of x0. Yeah, yeah. So for me, I think this is okay, but it's yeah, yeah. Someone asked about this. There's a YouTube video about this particular theorem as well. It's on my channel as well. So this one's a bit tricky.